going with ellipse, the discussions are fundamentally the same as that in parabola, where I discussed if a line is parallel to the y-axis, then its equation is x is c. If it's here, its x is minus c. If it's here, its y is c. If it's here, its y equals to minus c. This being the origin, equation of this is y is 0. That is equation of the x-axis. Equation of the y-axis is x equal to 0. Some discussions I have already gone with regarding the quadrants. This is plus plus, minus plus, minus minus, plus minus. So I'll suggest you to go with the parabola discussions and then come to ellipse, so that you will understand these all things quite easily, because overall the section is quite easy and interesting. A typical ellipse looks like this. This I have drawn using the tool, so it's not very much looking the ellipse that is there in a book. If I'll draw an ellipse freehand, somewhat it will be looking like this. Now this is the origin. This is x-axis. This is y-axis. If I'll say this as x, this is x dash, y, this as y dash. There's a point here, there's a point here. Now in case of a parabola, this point was called focus. Now in case of an ellipse, there are two foci. One is here, one is here. Thereby we have two latus rectum and obviously there will be two directrix. Now this is called center of the ellipse. This origin was called vertex in case of parabola. This is called major axis. You can see this length is more, so this is a bigger axis. Major is bigger. This is relatively small, so this is called minor axis. Sorry for the throat. Now coordinate of this focus is A0. This is also A0, but obviously this will be negative. These points are called vertices. There are two vertices. This is A0. This is minus A0. This is 0B. This is 0 minus B. This point is A by E0. This point is A by E0 minus. So obviously this equation of this line is x is equal to A by E. This is x equal to minus A by E with respect to these two lines parallel to the y-axis. This is called directrix. This is called directrix. So there are two directrix in case of an ellipse. Now the endpoints of the latus rectum. This is A, so this point has to be A. b square by a b square by ae b square by a b square by plus plus minus plus minus minus plus minus. Now how you understand, if this is a, this is also a, because if this point is 5 0, this has to be 5 something, depends on this. If this is 2, this is 5 2, so this 5 is remaining the same. Coordinate geometry as such is quite easy and interesting. So if I'll say this as v dash, then v dash is the length of the major axis. So this much is a, this much is also again a, so this is a plus a, that is 2a. Similarly, this point, these 2 points are the endpoints of the minor axis. Naming, I can give anything simply. Let me say p and p dash. So p dash is the length of the minor axis, and this is obviously, this is 0b, so this portion is p, this portion is p, so this is 2b. In the parabola discussions I have already mentioned, even though this is minus a, but the length is always a, because if you take this point and this point, one is minus a0 and one is 0 0, this take as x1 y1, this you take as x2 y2, and use the distance formula, x2 minus x1 whole squared plus y2 minus y1 whole squared square root, you will get a. You will not get a negative thing. Overall, the equation of the ellipse is x square by a square plus y square by b square is 1, and b square is a square into 1 minus a square. Here this a must be bigger than b. This e is called eccentricity. What it means for, you do not have to know for the moment. So some examples of this kind of an ellipse I can give: x square by 25 plus y square by 16 is 1. As this denominator, let me say this is d1, this is d2, this is d1, should be greater than d2, then this is overall called a horizontal ellipse. We'll also be discussing the vertical ellipse. You can make out it's just shifted like this, then it becomes a vertical ellipse.